Hello children, welcome to Akshara 8 Foundation. So myself I am Shivshankar, I am a physics teacher. Today we are going to discuss about the new topic, that is the center of mass. It is a new topic, that is the collisions. Okay. So in the last class we have completed linear momentum, we have completed. Okay. And the law of conservation of linear momentum we have completed, and there is a relation between momentum and the linear momentum and the kinetic energy we have completed, and we have solved some numericals, and remaining numericals will be complete in doubt session there. Okay. So next today we are going to see the in the center of mass topic only. It is a one more concept, that is a collisions. Okay. Collision is nothing but the interaction between the two objects while they are moving in the same direction or in opposite direction. Okay. The interaction, it will be in terms of colliding. So two objects will be collided. Suppose we can take the example as whenever the two objects are moving, like two cars are moving, or a bus or a car is moving on the road there. So when they are moving in same direction or in opposite direction, if they are moving in with different speeds there, with uncontrolled speeds, then the two bodies, two cars or two buses or two lorries or lorry and car, they may be interact okay, in with large forces. So when they are interacting with large forces, then so that phenomena, that is called the collision there, collision of the two objects there. Okay, collision of two objects there. Suppose if the two objects are moving in opposite direction, there is a collision, it may be takes place there. Okay. So due to the due to any reason, they may collide with each other. Okay, due to the careless driving or the speed. If it is over speed, then the collision maybe takes place there, or because of the road construction, there is a collisions may be happen there. Okay. So suppose that is in the, if the two objects are coming in opposite directions. Okay, if the two objects are moving, suppose two cars are moving in the same direction, and one car exceeds the speed, okay, than other car, then there is a chance of interaction of the two cars maybe takes place there, that in the large force, the interaction will be in the large force, then that is called the collisions. Collision between the two cars, we can say that. Okay. So then if the collision is taking place, interaction of the two objects in with large forces, it is taking place, then what is the what it is going to be takes place there? What is the linear momentum of the two bodies, and what is the energy? What happens to the energy? Okay, that kinetic energy, especially the moving bodies will have the kinetic energy, no? So what happens to the kinetic energy and the linear momentum before collision and after collision, that we are going to see now here. So today topic is collisions. Collisions. Okay. So collision is nothing but the interaction of the two objects, the interaction of, that interaction is nothing but what there? Colliding. The interaction of two objects, moving in same direction, or in different direction. Same direction or in same direction or in different direction. Different directions. Different is called collision. So that may be, it may not be two bodies are may not be in the motion. One body may be in the motion there, another body is in the okay. So it is in the motion there. Case also the two interaction of the two bodies will be takes place there. So that is called the collision there. Okay. This collision is taking. There are different types of the bodies after the collision. They may move in the same direction, and there is a change in linear moment. Change in linear momentum and the kinetic energy will be takes place there. So based on this change in kinetic energy and the linear momentum and the interaction after the collision, how the objects are moving in the same direction or in the based on this we have the different types of collisions are there. Okay. So now types of collisions. Types of collisions. So first one is the elastic collision. Elastic collisions. Inelastic collision. Inelastic collisions. Third one is head-on collisions. Head-on collision. Okay. Fourth one is oblique collision. Oblique collision. Oblique collision. Oblique collisions. So these are the four types of collision basically. So we'll see one by one. What is the elastic collision? What is the inelastic collision? What is the head-on collision? See there, okay. So now first one we'll see there elastic collision. Elastic collision, the collision in which both linear momentum and the kinetic energy is conserved. Then we can say that is the conserved means constant there. That is it is known as the elastic collision there. Okay. So here suppose the body has a mass m1 and it is moving with speed u1, and second body has a mass m2 and it is moving with speed u2, and then this is a before collision. So these are the speeds and masses, and during the collision it will be takes place, and after the collision they will be moved with different velocities v1 and v2 there. Okay. So now before collision there is a momentum will be there, that is a m1 u1 plus m2 u2. So that is denoted by here pi, initial momentum, and here the final momentum. After the collision they will be have the moving with the different velocities, that is v1 and v2. Then the final momentum will be, so pf is equals to m1 v1 plus m2 v2 there. Okay. So now conserve constant before and after collision, the total momentum will be constant, that is p initial is equals to p final there, momentum initial momentum is equals to final momentum. If you write there you will get a equation. This is the equation we will get here. Okay. So m1 v1 m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. That is the expression for the momentum, linear momentum before collision, and total during the in this process, total momentum will be conserved there, equal. Now next one is the kinetic energy. Kinetic energy also constant there. So before momentum there is a kinetic energy is half into m1 u1 square plus half into m2 u2 square. Okay. Next final kinetic energy will be half into m1 v1 square plus half into m2 v2 square. Then total momentum will be conserved there. Initial kinetic energy is equals to final kinetic energy. Initial kinetic energy is half into m1 u1 square plus half into m2 u2 square, that is equals to half into m1 v1 square plus half into m2 v2 square there. Okay. That is the, if these two are conserved constant before and after collision, then that is called the elastic collision. There is no loss of kinetic energy will be takes place in this collision there. No loss of kinetic energy in this elastic collision there. Okay. That is called elastic collision. Okay. Next one we'll see here inelastic collision. So the collision in which only the momentum, linear momentum will be constant, conserved, but not the kinetic energy. Kinetic energy will not be conserved there. So there is a loss of kinetic energy will be takes place in this collision. So here the kinetic energy will be not equal there, but linear momentum will be equal before and after collision there. So before collision the linear momentum m1 u1 plus m2 u2, and after the collision the linear momentum, final linear momentum will be m1v1 is m1v1 plus m2v2. Okay, so that will be equal before and after collision there, but the kinetic energy is not equal there. So in this collision, there is a loss of kinetic energy will be takes place there. Okay, this is a elastic inelastic collision. Okay, inelastic collision there. Next, see there. Next one is a head-on collision. Head-on collision. The collision in which objects will be confined to the straight line after the collision. Okay, the collision in which objects are confined to a straight line after the collision is called head-on collision. Head-on collision there. Okay, so now here, so they will be confined there. See here, suppose this is a mass of body m1 and it is moving with a speed u1, and it is the second mass of the body of mass m2 and it is moving with a speed u2. Okay, then they will be collide during the collision. So they will be have like this, and after the collision, they will be move in a straight line. So this also move in the straight line v1, and this is a m1, and the straight line they will be move. So along the straight line they will be move there. So m2 and v2, m2 and v2 there. Okay, so that is nothing but the if after the collision two objects are confined to a straight line, then that collision is said to be the head-on collision there. Okay. So now next one we have the oblique collision. Oblique collision. Oblique collision. Oblique collision. Oblique collision. So oblique collision is nothing but the collision in which the objects will not confine to a straight line. They are said to mean they will be moving in a different direction, in any direction. So that collision is nothing but the oblique collision there. The collision in which the objects not confined to a straight line, is said to be the a straight line is called oblique collision. Is called oblique collision. Oblique collision. Okay. Suppose the mass of the body is here, m1 mass of the body, and it is moving with a speed u1, and another mass of the body is moving with a speed u2. Okay, u2. Then after they will be collide here. They will be collide after the collision. One may be move like this with v1 speed mass m1, and other may be move in other direction there. So with a speed v2, okay, this mass m2. Okay, this type of collision is said to be the one is moving one side and other moving will be another side there. So that type of collision is said to be the oblique collision there. The type of collision is oblique collision. So now we'll see the next. Here we have discussed this is the introduction of all the types of collisions. Now we'll see there perfectly elastic collision there. So we have seen there perfectly means elastic collision. So in that collision the linear momentum and the kinetic energy is conserved there. Then we are going to find out the final velocities of the objects there. We are going to find out the expression for the final velocities. So initially they will have the u1 and u2 speeds, and after the collision they have the different velocities. No? So here v1 and v2. What is the expression for them? v1, v2 expression. So how it would be, that we are going to find out there. Okay. So now we are going to see in the perfectly elastic collision there. Okay. Now the perfectly elastic collision right on there. Perfectly elastic collision. Perfectly elastic collision. So perfectly elastic collision is nothing but there is a conservation of linear momentum before and after collisions will be there. Okay. So conservation of linear momentum will be there and conservation of energy will be there, kinetic energy. So now we'll see the first. So let us consider this is a mass. M1 mass of the body is moving with a speed u1, and other mass m1 mass of the body is moving with a speed u2, and this is a before collision. So before collision, if the u1 speed is greater than u2, then they will be collide any object. So here u1 should be greater than then it is a chance of they are moving in the same direction. If u1 is greater, then they collide. Okay, in the same direction if they are moving, there is a chance of colliding of objects there. So this during the collision they will be collide here. Okay, so during collision, then after collision, so one body will be moved with the speed of v1, okay, and in the same straight line another body also moving there. This is a perfectly elastic head-on elastic collision we can write here. Okay, so this is the v2. Okay, they are moving in the same direction there. They are moving in the same direction. Okay, then here you see there before collision there is a momentum, that is p initial pi, that is m1 u1 is equals to m1 u1 plus m2 u2, and final momentum here, final momentum p final pf, that is a m1 v1 plus m2 v2. So now it is a conservation, means linear momentum will be conservation. So then here law of conservation of linear momentum, we can write this here, then the expression will get here m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2, we can write there now. Okay, now m terms we will bring one side and v terms we can bring other side there here. So we can write here m1 minus here if you take m1 common, if you bring this side here, we'll get there m1 we can take common m1 u1 m1 v1. So m1 u1 minus m1 v1 there. Okay, now m we can take common here, u1 minus v1 will be remain, and it is m2 u2 is at that side, it will become there m2 we can take common here, v2 minus u2 will be there, v2 minus v2. Let us consider that is equation 1 there. We should consider that is equation 1 there. So now here we can write there, so kinetic energy, initial kinetic energy, Ke initial, what can we write here, half into m1 u1 square plus half into m2 u2 square, half into m2 u2 square. So m2 u2 square, and final kinetic energy K final what we will get here, half into m1 v1 square plus half into m2 v2 square, half into m2 v2 square. So according to same law of conservation of energy we will get here now. So that is the initial kinetic here. So kinetic energy will be equal to the, so Ki will be equal to the K final. So the law of, according to the law of conservation of energy. So what can we write here now? So Ki is nothing but half into m1 u1 square plus half into m2 u2 square, that is equals to half into m1 v1 square plus half into m2 v2 square. See here, the both the side in this equation, both the side of the equal, there is a half is a common, so we can take common and we can cancel there. If we cancel there, we'll get like this now, this equation. So we'll get the equation like this. So m1 u1 square plus m2 u2 square is equals to here m1 v1 square plus m2 v2 square. Now m terms we bring one side, and m1 terms we should bring one side, m2 term we should set other side there. So if you bring here m1, we can take common now, here it will be remain there u1 square minus v1 square, and this m2 u2 is on that side. From there we can take m2 common, so that remaining is here v2 square minus u2 square will get, let's consider this is equation 2. Now divide equation 2 by 1, divide equation 2 divided by equation 1. So what happens, we'll see there here, this is equation 1. So m1 u1 square minus v1 square, okay, so that is equals to here m2 v2 square minus u2 square So then here we got there m1 u1 minus v1 we got there from the first equation. This is a m2, here we'll get there v2, m2 what will get there? So v2 minus u2, no, this only we got now here, we see here in this equation. So m1 u1 minus m1 into u1 minus v1, m2 into v2 minus u2. So that only we wrote now here. Here we wrote that only. So here m and m will be cancelled and m and m will be cancelled. So now what can we write here again? That equation, the above equation can be written as, so v1 square minus u1 square minus v1 square. A square minus b square form, we can write like this, no? So u1 plus v1 into u1 minus v1 we can write divided by, so u1 minus v1 we can write here, that is equals to v2 plus u2 into v2 minus u2 divided by here, so v2 minus u2 is there, v2 minus u2 is there. Now this and this will be cancelled, this and this will be cancelled now. Now the remaining equation what we get here, that is a u1 plus v1 is equals to v2 plus u2 plus u2. Now initial velocities has to be bring one side and final velocities we can send other side there. If we bring here this one, so u1 minus u2, if we bring u to this side and if we set this that side, v2 minus v1 we can write there. So what can we write here? This is the velocity of approach and this is the velocity of separation. So when they are coming to collide each other, so they are approaching. So if they are moving with initial velocities, then the change in velocity it is said to be the velocity of, they are coming towards each other, or we can say the two bodies are moving in the same direction, no, they are moving. So one body is moving with large speed and colliding the other body there, okay. So then this is we can say this is the velocity of, it is the velocity of approach, and that is equals to velocity of separation, velocity of separation. Velocity of approach is equals to velocity of separation, we can say. So this is the equation, we'll get, this is the basic equation. Now from this equation, our aim is to find out the final velocity v1 and v2. Suppose from this equation, let us consider this equation as here 3, okay. So now if we write here, if you write here v1 is equals to remaining all, if you write there, we'll get the v2 equation, and if you write here v2 is equals to, if you write remaining all the equations, then in any one of the equation, whether it may be in the first equation or in the second equation, this term if you substitute there, we'll get the final equation there, okay. So now here we'll write there v2 is equals to, so from equation 3, if I write like this, v2 is equals to, we can write like this, no, v2, if I write v2 is equals to, like this we can write u1 minus u2 plus v1 we can write there, u1 minus u2 plus v1, okay. So v2 is equals to, like this we can write now. Now if this is substituted, substitute this v2, v2 in equation 1, So v2 value we got now, this u1 minus u2 plus v1. If we substitute their equation 1 there, where is the equation 1? Equation 1 is here there, where? This is the equation 1. So what we got there, v2. In place of v2 is here in place of v2. So what is the value we got here? That value we should substitute here, u minus v2, u minus u2 plus v1. We should substitute, then we'll get the expression in terms of v1. Means, so final velocity of the initial body we will get there. So first body otherwise, okay. So now we'll see there, if we substitute there, what we got here, equation v2 is equals to u1 minus u2 plus v1, Now if we substitute there, so what is the equation, first equation we got there? So m1 into, so here we got there u1 minus V1 is equals to M2 into. So V2 no, V2 in place of V2 what we should write there? U1 minus U2 plus V1. Okay, this is the V2 minus what should we should write there here? U2 minus U2. Okay, so what it will be happen there here? Multiply this one M1 U1 minus M1 V1. So here you see there here. So this will become M2 U1 plus M2 V1. Here minus U2 and U2 minus U2 minus 2U2 will become no. So minus now M2 has to be multiplied here minus 2 into M2 into U2 will be there. Okay. So now if you bring this term, if you bring this both the terms this side, okay. So what happens here? U2, U1 and U2. So we should find out V1, no? So V1 we should find out this V1. Okay, one thing we'll do there, this minus M1 V1 will send that side and remaining all will bring this side there. Okay. So M1 V1 will send that side and remaining all will bring this side. So then we can write like this there. Okay. So M1 V1 plus M2 V2. I am sending this that side, I am writing here, okay. I am sending this term that side and remaining. So now here what happens there this side? M1 U1 minus M2 U2, sorry M1, M2 U1 and this one here plus 2 into M2 U2, 2 into M2 U2, okay. So now here from this V1 we can take common. If we take V1 common here, so M1 plus M2 into V1 we can write now is equals to, here U1 we can take common here. If you take U1 common, M1 minus M2 into U1 we can write plus 2 into M2, here U2 we can write there. Now send this M1 plus M2 that side. Okay, what do we get now? So we will get the V1 value. V1 is equals to what happens here now? So M1 minus M2 into U1 plus 2 into M2 into U2 divided by M1 plus M2 we can write now, M1 plus M2. Therefore, here, so here we can write there V1 is equals to, so M1 minus M2 divided by M1 plus M2 into U1 we can write there plus 2 into M2 divided by, so M1 plus M2 into, so U2 will be there. Okay, this is the expression of the initial expression of the final velocity of the first body. After the collision, so with this final velocity, the body will be moved there. Similarly, we'll get here. So V2. Similarly. So V2 will get there. V2 is equals to, will get here. V2 is equals to, so 2 into M1, here M1 plus M2 into U1, okay, plus, here we'll get there M2 minus M1, here M2 minus M1 divided by M1 plus M2 will get there. Same we have to do there. What we have to do to get this one? This equation. To get this equation now, here we have written the third equation now. Here. In the third equation, what we from the third equation, what we have written here? V2 value. V2 is equals to, we have written there. V2 is equal to this value we have written there. If here V1 is equal to, if you write there, V1 is equals to, if you write V1 is equal to, what happens there here? This will come here. V2 minus U2 minus U1 will be there. That value if you substitute in equation 1, then we'll get by this simplification we'll get this equation there. The same manner, so we'll get this equation. So we got the expressions of the initial velocity and the final velocity we got there. So now, so today up to here it is enough. Then in the next class, tomorrow class, we are going to see the different cases. So here if the body is at rest, and if the body is at rest means velocity will be, initial velocity will be 0 of any object there. So then different cases we are going to see in the next tomorrow class. Okay. So thank you children. Have a nice day.